variables that you have seen till now were created by the author of the script. Such variables are static. The developer initiated the variables with values, and next, instead of using some strange static values, he or she used the variable names. That's already something better than using the static values, but it would be much better if the variable could have value returned by another command. Such variable would be dynamic. Depending on the value returned by a command, the value of the variable would be updated. Later in the script, such value could be somehow used. Let's see the examples how to save results returned by commands into the variables. The first example will use the command df returning information related to file system usage. It describes the size of the file system, how much of the space is used, how much of the space is available, how much % of the disk space is used. When df is started without parameters, it displays such information for all file systems. However, if you want to check only one file system, it's enough to send its mount point as a parameter for the command. Here I will display information for home file system. Let's say I want to get information about free space on the file system. Moreover, I want to display such information in readable format, so I will start it with the option H, like human. Here the value is 975 megabytes. That's okay. To extract this value, first of all, I should remove the header from the output of the df command. Grep can help with that. Grep can select from a set of lines, can choose only those that match to some condition, or better say, to a mask. Grep can read data coming from a pipeline from the standard input. Among other parameters, we have here parameter v, invert match. In other words, this parameter will return only rows not matching to a mask. The command df-h home will pipe the result into grep. Grep will return all values not matching to the mask file system. File system is the first line of the df output. In other words, this instruction allows me to exclude the first line, header. Only a line related to file system home is returned. Good, but currently the result is just a text separated by spaces. We would like to get only the fourth column from the information related to the free space on the file system. The command that may help here is the cat command. For command cat to work, the fields that should be extracted must be separated by a single space. And here we have less or more spaces. What to do? Another command, tr, can help here. One of the available options is s. It will convert sequence of repeating characters into a single character. I will call the previous command and the result will be sent to tr. Here, option S defines that every multiplied space should be replaced with a single space. Now it's much better. We have a quite nice result returned by the df command without a header and without repeating spaces. So let's have a look at the cat command. This command can cut some substrings from the original text. This text can be read on the standard input. In our case, the incoming by the pipeline text should be cut into smaller pieces depending on a separator. This separator is named here delimiter. To define it, use the option D. Using option F, we can point which field should be returned. It's time to construct the next part of the pipeline. The result of the existing pipe will be sent to cat. Cat will split the text using space as delimiter. In last step, only the fourth field will be returned. So, I have the final result, just one value. How to save this value into a variable? That should be easy. It's enough to assign to a new variable this expression enclosed into $ and brackets. Here the variable name is home free. After executing such a command, nothing should be displayed on the screen, but the variable value should be changed. Now we can use it somewhere in the script. So starting from now, we have in our script a variable with dynamically assigned value. Here, a next example. As you already know, the file extension of the file in Unix does not have any special meaning. The file is executable when the permissions to the file are set up correctly. If you have a file with extension sh, but the permissions are read and write only, this is not an executable file. But maybe we are able to develop a script that will grant the execute permissions to the files with sh extension. Let's do it. The script will be named make_exec. Into the files variable, I will save the result of a command ls**.sh. After running this line, I will have in the variable a list of file names. I could now add execute permission to all those files. The arguments that I pass are the definition of newly granted permission and the variable files. Unfortunately, the script is not so powerful that it could add itself the execute permission, so I need to do it manually. Note that currently in the directory we have one file with extension sh, but which is not executable. When I only run the script, the file should get the execute permission. Now the file name is displayed in color, and it means we have a success. It is, however, possible that in the scripts that you would need to analyze and change, another solution will be present. Instead of writing $ and brackets, you can see the reverse apostrophe. This reverse apostrophe works like $ and brackets. The only difference is that reverse apostrophe is a standard that should work generally in every shell. You can find this character on your keyboard on the same key as the tilde. In this lesson, you have seen how to save commands results into variables. Next, the variables could be used in the following lines of the script. We will use this method frequently in our scripts.